Hello, here's a video for 4.1.1, and we're going to introduce something new that we call a variable. And it's very odd, it's a very different thought, where as we move here through math, we get more letters in math actually. Okay, let's get going. The top three problems are merely review problems. They are ones that you should be able to do. So go ahead and pause and try them on your own, and then come on back. All right, I'm going to quickly go through these division problems right here, and I am going to go pretty quick because you can always pause and rewind, and same concept throughout the whole video. Alright, so when we are doing a division one, and I have a whole number on the outside there to the left, I can just move that decimal place up, here to do my division. Then everything else is just dividing as normal. So how many 4s go into 37? 9. And we are subtracting here. 7 minus 6 is 1. We drop that 6 down right here. How many 4s go into 16? 4. 4 times 4 is 16, and that's 0, so we're happy there. So 37.6, 37 and 6/10 divided by 4 is equal to 9 and 4/10. Let's do this one. We have a 2, 7.3, or 7 and 3/10. Again, the 2 is a whole number, so I just moved the decimal point up. How many 2's go into 7? 3, 6, 1, drop the 13 down. How many 2's into 13? 6. 6 times 2 is 12. We have a 1. Now what? Well, we can add as many zeros as we want. No harm, no foul. So I'll drop one of these zeros down. How many 2's go into 10? 5. I guess I only needed one extra zero, not 4 extra ones, huh? All right, and then let's do the same thing with this one here. We have a 5, and we have 21. How many 5's go into 20? 4 times that, and we subtract, we get a 1. It looks like I'm going to need some extra, so I'm going to slip a decimal with as many zeros as I want. Doesn't matter, still 21. So then I'm going to drop one of those zeros down. How many 5's go into 10? 2. 4 and 2/10. All right. So 411 is what if I don't know this length, and we're going to introduce, as I just said, this thing called a variable. So in the last chapter, you worked with lengths moving back and forth on a number line and comparing signed numbers, plus and minus. But what if there are lengths you do not know? In this lesson, you will use clues to find unknown values. Unknown values are often represented by variables. Finding unknown values is one of the most important parts of algebra. Today's work will give you the background you need for upcoming work with variables. As you work with your team, in this case it will be by yourself, keep these questions in mind. How can I represent or visualize this information? What information do I know? What information do I need to find? So here's our first problem. Croaky the talented frog. Croaky is a very talented frog. He does tricks for the audiences at the Calaveras County Fair contest every year. Some of his tricks are quickly making him famous. He not only hops, but he can also do a hip-hop jump along with other exciting tricks. Just how long is this hip-hop jump? Assuming he travels the exact same distance each time. Read the description of his special routine below. Then complete parts A through D that follow. Croaky starts at point A. He hops 12 feet to the right toward point B. He then does 2 hip-hop jumps in a row, still traveling to the right. He turns and makes a 3-foot hop to the left. He stops to regain his balance, then still traveling to the left, repeats his 3-foot hop 3 more times. He turns and makes 16 spinning hops that are 1 foot each to the right, ending exactly at point B. Okay. Don't worry about where point A and where point B is in here. We're going to draw a diagram. So to draw a diagram, we will not be using a number line. And the reason we're not going to do that is because of these hip-hop jumps. We don't know how large they are, so we don't know how big they're, or what value to apply them to if we're on a number line. So what we do is we draw a rough sketch or diagram of that just to represent its movements. Okay, so here we go. Let's start with blue. As Croaky starts, he hops 12 feet to the right. So I'm going to start with this blue here, and so we have 12 hops to the right. Okay, or 12 hops 12 feet to the right. Sorry about that. And so here we start. I don't know where it is, but it's a plus 12, right, to the right. Then he does 2 hip-hop jumps in a row, still traveling to the right. All right, so I'm going to use a different color for that because that will help us to see the color correlation here. So 2 hip-hop jumps, and there's 1, here's 2, right? So how do I represent these hip-hop jumps? And that's the key part for today. We don't know what those are, so what we do is we use a variable. And a variable is a letter that represents a particular numerical value. The nice part is we can change that number sometimes, plug it in and kind of plug it out. So in this case, maybe H could be a great representation for a hip-hop jump, right? Because that letter H could represent that jump. He turns and makes a 3-foot hop to the left. Okay, so we have a new color here. And a 3-foot hop to the left. So we don't know exactly what that looks like, but I'm just going to move it up here. It could be bigger than H, it could be smaller than H. I don't know. All I'm doing is just making that, showing that value there. He stops to regain his balance, then traveling to the left, repeats his 3-foot hop 3 more times. You know what? I'm going to keep that same color for this one because there's not really a change to what he's doing. So how many times does he do that? 3-foot hop 3 more times. So 1, 2, 3. So that's a -3, -3, -3. And then he turns and makes 16 spinning hops that are 1 foot each to the right, ending exactly at point B. Again, I don't care about point B. Instead of doing 16 little hops of this, I think I'm just going to put it in one group or whatever for that. So let's get ourselves, that's 16 that are 1 foot. So let's just do that as one big group here. I don't know where this goes. I'm just guessing. Guessing where it could be. This has got to be point B. Okay, so if I mark that now, this is A, this is B. Now again, because I don't know how big these H values are, if they're 100, right, that really makes this a whole lot different. But what if H is 1? And you can see how differently this picture would maybe look, right? We don't know. All right, work with your team to write an expression that represents the distance from point A to point B based on Croaky's moves. Thankfully, with these color coordinations, we can realize that what happens, he first makes a jump to the right, so we call it a plus 12, right, or moving to the right there. And then we have 2 hip-hop jumps, so we'll count that as a plus H and a plus H, right? Actually, you know what? I want to give myself a little room here, so I'm going to slide this up. All right. Then we have 4 hops, I guess, really, right, to the left. So we could do -3, -3, -3, -3, 4 times. And then what do we have at the end? We then have our 16 to the right. There we go. Now the reason I gave it a little bit of space is because you can combine stuff, can't you? And so what we'll do is we'll write that as a 12. I don't know why I slid that up there. That happened though. I'm going to leave the H like this, plus H, and I'll talk about that in just a little bit. When I subtract 3, subtract 3, subtract 3, subtract 3, I'm moving how far to the left, right? How far to the left am I really moving? This whole thing is a -12 to the left, right? So I can do a -12, and then I can do my plus 16 here at the end. Now, let's leave it at that for today, okay? Notice we just simplified it a little bit. Jill is one of Croaky's biggest fans. From watching his act, she estimates that his hip-hop jumps are each 5 feet long. 5 feet long. If Jill is correct, how far is that from point A to point B? So if each hip-hop jump is 5 feet long, I'm going to mark it in the color, right? The hip-hop jump is, whoops, I'm using the wrong color. Hip-hop jump is 5 feet, right? Because it is the green part of our jump, right? So when I do that, let's go, that's the 12, right? Plus, now each one of these, why is that disappearing? Each one of these then is 5 plus 5. Then I could do my -12 plus 16. And then what I can do is I can combine all of that, right, and put that together. So I'm going to go to switch to color here. 12 plus 5, that's 17, plus 5 minus 12 plus 16. 17 plus 5 is 22, minus 12 plus 16. And then 22 minus 12 is 10. So I'm just going to move that up here. 10 plus 16, 26. So how far is it from A to B? 26 what? Oh, I should label that. That is in feet. That's in feet, we find out. Okay. Croaky's manager measured the distance from A to B and found out it was exactly 24 feet. Uh-oh. How far does Croaky really travel each time he does his hip-hop jump? Use pictures to help explain your thinking. Be prepared to share your thinking. All right. So in here, when we really find out that this 26 is just a little too big, right? Because remember, she just estimated. She didn't really know his distance. We actually found out that he didn't go 26 feet, that he went 24 feet. Okay, and if he goes actually 24 feet, that means that each of these hip-hop jumps are actually not 5 feet, but they have to be less. So for now, you could just do some guessing. And what you'll find out is that each one turns out to be 4 feet. Whoops, let me change that to the color of what we're using here again. Each one officially becomes 4 feet. And I will let you plug in that 4 instead of a 5 up here to find out that it actually works. Okay? Now Croaky has a new special jump. He moved between two fixed points, each time with a different sequence. His trainer, Tom, drew a diagram below to represent his two sequences, using Y to represent the length of Croaky's new special jump. Describe each of Croaky's new sequences in words. I'm not going to write it, but I am going to say that in words, and you can write this, right? So the first sequence, it looks like he does it have a name for it? I'm sorry if I missed it. New special jump, so we don't know what it is. So we have 3 special jumps to the right, and then one big jump of 5 to the right. The second sequence has 2 of these special jumps, but then it has one big jump of 8. All right, so let's figure out how far Croaky travels in each special jump. Well, we don't know how far he goes overall, right? We don't know the beginning to the end, so it's really hard for us to figure out. But what we're going to do is we're going to do a little trick here. I'm going to take, and just for a second, I'm going to try to hide some of this stuff, okay? And what I'm doing is hopefully simplifying this so that you see, right, that distance, 8 to the end, is got to be the same distance as Y to 5. Okay? So what distance must that Y be? Well, that Y has to be 3. It has to be 3 because 3 plus 5 gives us the full 8. And that helps us to find the whole thing, right? What is the distance between the start and end of the jump sequence, right? Well, I can do the top one, which is 3 plus 3 plus 3, or 9. 9 plus 5 is 14. Or I could go down here and I could say 3 plus 3 plus 8, right, to give me 6 plus 8, which is also 14, right? There we go. Good deal. Last problem, even though we have other ones down below. Croaky has a new set of moves. This sequence involves 3 special high hops. The expression x plus x plus x plus 5 represents the whole sequence, with x representing the distance he moves with each high hop. In your words, describe what you know about Croaky's new sequence. I'm not going to write it. You can write it. Croaky has 3 high hops to the right and another hop of 5 to the right. If Croaky's new sequence is a total of 11 feet, draw a diagram to represent Croaky's new sequence. Okay, so let's draw that diagram here. We can think about that diagram like this, right? X, and then X. I'm going to switch that up, sorry. And then another hop to the right of X, and then a last hop of 5. Okay, there we go. And then what do we know about it? Well, we know that the whole length is 11 feet, right? Okay. How far does Croaky jump with each high hop? How can you tell? I'm going to let you stop, pause, see if you can figure that out. What would it be to go? And then what that would make it, so there'd be 11. So I'm guessing that maybe you did a little bit of guessing. I'm guessing you did some guessing to figure out that x will turn out to be 2. And what we can do is say 2 plus 2 is 4, plus 2 is 6, 6 plus 5 is 11. Okay, I'm going to skip 4, 4, skip 5, 4, 5 here, and then this is actually in your ebook, but it just shows a little bit of division in here. If you want, you can always pause and just take a glance at this. Okay, if you have any other questions, please ask. Have yourself a good day.